Assalamualaikum warahmatullahi ta'ala wabarakatuh and a very good morning. First and foremost, I will introduce myself. My name is Azlin binti Azmi. Currently, I am a third year student of physics in University of Tun Hussein on Malaysia. And today, I will present you my title, Combination of Cobalt Ferrite with Sugarcane Bagasse Paper via Irradiation. For your information, my research was being supervised by Dr. Siti Amira binti Othman from Faculty of Applied Science and Technology, FAS, of UTHM. Now, let's move to the next part, Introduction. Nowadays, paper is a medium that has been used mainly for writing, printing, and packaging. According to Roda and Rati 2007, Malaysia already listed the second highest demand for paper usage in the Asian region. Also, Malaysia is a globalization nation where the growing demands for the usage of paper are due to the broadening of community. Therefore, sugarcane bagasse offers a sustainable utilization as an alternative in the paper-making industry. Next, let's move to problem statement. First, excessive deforestation might worsen environmental problems. As we know, wood contributes to the degradation of woodland resources. Thereby, the deforestation might worsen the environmental problems, such as flash floods and global warmings. Next, destructions of habitat. Apart from this, deforestation even induces the change of other ecosystems. After deforestation, many types of flora and fauna species living in the forest cannot withstand as people demolish their biodiversity. Third, fungi may cause spots or stain on paper and may affect the integrity of the paper. The existence of fungi could affect and risk health. To avoid this risk and infection, the radiation can be carried out to the paper. So, let's move to the next part, objective of study. There are three objectives in this study. First is to study the mechanical and physical properties of magnetic sugarcane bagasse paper by using scanning electron microscope, energy dispersion X-ray, theoretic tester machine, and Fourier transformation infrared spectroscopy. Next, to study the effect of the magnetic material in sugarcane bagasse paper during pre- and post-irradiation by gamma cell. And finally, to study the suitability of magnetic material as a filler for sugarcane bagasse paper. For scope of study, this study focuses on sugarcane bagasse fiber resources. The samples were used in the form of particles 4 × 4 cm to study their physical and chemical properties, morphology, characterization, respectively. Next, sugarcane bagasse fibers and magnetic material, which is cobalt ferrite, were used to observe the radiation effect in the paper. Sodium hydroxide at concentrations of 1 molarity is used to test the concentrations of sodium hydroxide effect on the bagasse and the effect of pH on the cobalt ferrite sorption and precipitation. For scanning electron microscope was used to determine the properties and the surface morphology of the magnetic sugarcane bagasse paper. For theoretic tester machine, it was used to study the mechanical properties of the magnetic sugarcane bagasse paper. While for Fourier transformation infrared spectroscopy, FTIR, it was used to determine the functional group of the magnetic sugarcane bagasse paper. Now, let's move to the literature review. Why we use sugarcane bagasse as paper? The choice of sugarcane bagasse as paper was due to the research journal and article I've read. According to the research paper written by Saiful Azhar Saad et al. 2007, it states that bagasse is a popular supply in the paper industry. This statement was supported by Samariha and Kakifirus 2004 that shows that sugarcane bagasse is an abundant, inexpensive, available, and renewable sources. Also, Nur Suzairina Muhammad Sultan 2007 highlighted the attractiveness properties of sugarcane bagasse such as low specific weight, renewable source, and low cost. For your information, the quality of fiber produced from non-wood material depends on the content of cellulose, hollow cellulose, lignin content, and ash content. Therefore, higher cellulose can provide stronger fibers, thereby increasing the quality of paper produced. In addition, sugarcane bagasse also have low lignin content. By having lower lignin content, it is easier to discard from the pulp, and the paper that will produce is greater quality compared to the other non-wood materials. Next, Magnetic material as filler in paper. According to R.A. Gill 1995, the introductions of filler can improve the paper properties such as texture, opacity, brightness, ink absorbency, and overall printability. And the main reason to associate with the magnetic material is because magnetic paper exhibits some superiorities in properties such as a good mechanical properties and folding resistance. Radiation exposure on magnetic paper production. The credibility of paper may decrease due to the presence of bacteria and fungi. Therefore, to increase the integrity of the paper, irradiation by using gamma ray to the paper is to avoid the fungi and bacteria that can degrade the quality of the paper caused by the spot and stains. But how to do this? These are the materials and equipment that will be used in the research. There are two materials, which are cobalt ferrite and sodium hydroxide, and four equipment, which are scanning electron microscope, Turing tester machine, Fourier transformation infrared spectroscopy, and pH meter. Next, I will show you the flowchart of this study. In the production of magnetic sugarcane bagasse, the main materials are sugarcane bagasse, sodium hydroxide, and cobalt ferrite. Next, preparation of samples undergoes lumen loading process by mixing the sugarcane pulp with the cobalt ferrite. After the magnetic sugarcane bagasse was ready to use, the paper was cut into 4 times 4 cm to radiate in the gamma cell irradiator. To fulfill the objective in this study, the samples were identified by using scanning electron microscope, Fourier transformation infrared spectroscopy, Turing tester machine, and pH meter. Next was data analysis, and finally, results and discussion. For expected result, in order to fulfill the objective of this study, I obtained the result by other researchers that's similar to this study. For first objective, paper written by CoFe₂O₄ et al. 2017 shows the sugarcane bagasse samples were exposed to gamma radiation, and the difference in color, texture, bulky density, and morphology was being observed. For effect of texture, color, and bulk density, the table shows that the color of unirradiated sugarcane bagasse was off-white, which remains unchanged on gamma irradiation exposure up to 100 kg. When the irradiation dose is raised to 500 kg, the color transforms to yellow, while brown at 2000 kg. At 500 kg doses, the unirradiated sugarcane bagasse texture was hard and then fluffy when it comes to 500 kg and 1000 kg. While at larger doses, 2000 kg, it was entirely disintegrated into the powder mixture. This statement by CoFe₂O₄ et al. 2017. Besides that, the bulk density of unirradiated sugarcane bagasse was quantified at 83 kg per meter cube, which modified to 154 kg per meter cube at 2000 kg. Next, effect of chemical constituent. As shown in figure 2, the irradiated sugarcane bagasse does not show much change in lignin, ash, and moisture content. The hemicellulose component of sugarcane bagasse gets more affected on radiation exposure, which is reduced on 100 kg exposure and further decreased to at 2000 kg dose. The content of cellulose of irradiated and unirradiated sugarcane bagasse samples present no significant change in the cellulose content up to 100 kg exposure. However, on further exposure to 500 and 1000 kg, the cellulose content decreases respectively. Further exposure of bagasse to 2000 kg dose, the cellulose content reducing more. Next, effect on morphology. Figure 3 shows the morphology of bagasse irradiated with gamma ray of 2000 kg by using SAM. It shows the existence of pores in the bagasse lignocellulosic components. Thus, it is evident from the micrograph that the pre-treatment exposure of gamma irradiation of sugarcane bagasse opens up cellulose, making the cellulose more accessible to acid and hydrolytic enzymes. Next, let's move to comparison by pH reading of bagasse paper in the research by Muhammad Sultan et al. 2018. As shown in the figure 4, after the chemical treatment of sodium hydroxide took place, the color of the treated Bagasse fibers changed as the sugarcane Bagasse fibers turn into yellowish. This is made due to the removal of the impurities that exist on the surface of the fiber. In addition, it may be attributed to the eliminations of waxy layer and impurities from the surface of the fiber. Suitability of magnetic material on sugarcane Bagasse paper. First, sugarcane bagasse are lightly attractive to produce magnetic paper. According to Oscar H. Penneres et al. 2020, usually magnetite been used in the production of magnetic paper, but since the cobalt ferrite, which have controlling content that make it more stronger than the magnetite, it is more ideal to produce magnetic paper. Cobalt ferrite is recognized as hard magnetic substance with distinctive properties. Finally, according to Penneres et al. 2020, we can conclude that incorporations of sugarcane bagasse to be coated with magnetic material, it is suitable for the paper making. In conclusion, my innovation paper, which is magnetic sugarcane bagasse paper, should work just like any other paper available in this world. Yet, due to its innovation, it will provide a lot of beneficial to people. And of course, it can be commercialized for paper industry in the future. These are the reference from my presentation. That's all from me. Thank you.